Well, today it looks like we're going to be working on this battery. I connected this battery up to a device that pulled more than 100 amps. That's what the BMS is rated inside for. For instance, a power inverter, which some power inverters can pull as much as 300 amps to start certain stuff. And anyway, I hooked it up and it took more than 100 amps rated on the battery for the BMS. And give you a demonstration how I damaged this battery. I've got the voltmeter hooked up showing 13.54 volts, which is fully charged. And whenever I put my test light on it, well, you can watch here what this thing does. It drops down to 8.53 volts. So the BMS has been damaged inside this battery, and we're going to see if we can pull this battery apart, see if we can find the problem with the BMS and repair it, and see if we can get this battery operational again. It looks like the battery is sealed up. I don't know if they used the glue or what they done. I'm going to try to work with it. I don't know. I think they may have glued it along here. It's been welded together with a special machine where it heated the plastic up on this end and the other end. When they stuck it together, it welded shut. But I'm going to be probably making a wire. I'm going to put across right here and just take a hot wire and just kind of go through the casing to melt it all the way across. Wire I'm going to probably be using is going to be this 30 thousandths welding wire right here. I'm going to take this wire and twist it up in such a manner that I can make me a cutter with this, where I can cut that plastic all the way down through there with very little damage to the outside, so that we can put the battery back together and seal it off so that it'll be watertight, so we don't have to worry about water getting in it. I may eventually put a bigger BMS in this battery with a heat probe in it. So if the battery gets hot for overuse, it'll just cut the BMS off. And when the battery cools off, it'll do just like your cell phone. When it cools off, it'll go back to being able to use it again. So, but today, I'm just going to try to fix the BMS in here. See if we can get that up and running again so we can use the battery. And then we're going to look on the markets to see if we can find a bigger BMS or higher amp that let me put it in here. And I need to find out how many cells this is, if it's a 3 or 4 cell. So that I can't order a BMS till I figure out what cell I need. What kind I need for how many cells it has in it. So once we get it apart, we'll be able to determine what all we're going to need to maybe upgrade the BMS in this battery and reuse it. I do want to state the person that sold me the battery on eBay. I got with them and told them what I done. I told them I put it on a power inverter. And I tried to pull too many amps with it. And when I did, it blew the BMS out of it. The battery's not functioning. And the person on eBay was very helpful. They're actually going to send me another battery. And I'm going to probably do it the same way, because I need 2 of these batteries. And I thought I could use this on solar for a power inverter. Well, if you use these type batteries on a power inverter, and say your appliance takes 1,500 watts to start, well, you need at least 4 or 5 of these batteries to produce the 500 amps that you would need for a refrigerator to start, for instance, so it don't overload the BMS and blow it out so the battery is useless. So if you had 3 batteries and you plugged in your refrigerator, and the refrigerator needed to pull 400 amps to start the compressor, well, you're going to burn all 3 of your batteries out simultaneously with no warning. It'll just go, it's done. And your batteries are junk until you go into them and repair them. So that's what we're going to do today. We're going to pull this battery apart, and we're going to see if we can repair this battery, get it back able to use it again. And I'm also looking in the future buying a bigger BMS to put in it with a heat sensor. So if it gets hot being overused, it'll shut the BMS off until the battery cools off, and then the BMS will kick back in so I can continue using. All right, we're going to try to see if we can get this wire fixed up. Get this thing done in such a manner. I'm inside the field there. I'm trying to run the camera by myself today. Give me a pair of pliers here. Kind of squeeze everything together. I got to figure out what length I need so it don't overheat the wire whenever I'm going to use electricity to heat the wire. And this thing just keeps coming off. I'm going to use electricity to heat the wire, and that heat will actually all right, let's see if we can get this here held and twisted properly. All right, we got that twisted. Now I got to figure out what length I need it. Figure out what length I need it, then I can make my connections here and over here. Put power to the wire, and then it'll melt right through that plastic. That's what I'm planning to do. All right, the way I'm going to do this is I'm going to have my wife come out here and help me. I'm going to run me 2 wires from my trailer plug here that I use to check trailer lights with over to this wire here, and she's going to flip this switch here for me. And this is on the circuit breaker. I think it's a 30 amp, but I don't think I'll be pulling that much through this wire. But she'll flip the switch on as I need it to supply power to this wire to heat it up so I melt through the plastics. What I plan to do now. That's what I'm getting ready to do. I'm going to try to figure out what length I need for a 12-volt battery so yes, it'll get hot, but not just melt the wire where it blows in two. That's what I'm going to work on next. I'll probably time a lapse me fixing the wire up, getting everything set up to power the cable cutting here. So I'll probably time a lapse all this, fixing, hooking all this up, getting it ready to go. All right, the reason I doubled the wire right here and twist it together is this will carry twice the amps. And this here won't be getting hot when this does. So that's why I twisted the wire here up to this point to give me a connection there so it don't be melting into my copper wire there. All right here's what it made. I'm gonna have my wife here in a minute to help me with it, and we're gonna melt a hole through this battery and see if we can get that thing set up to open up so we can get in there to actually pair the BMS. I'm gonna be clamping here with a pair of vice grips to ensure that I don't pull the wire out right in the middle of doing something and then it falls over here on the battery and melts something I don't want to melt. So I'm gonna make sure I've got this thing clamped in a way that I don't have to worry about something coming loose or falling loose and it damaging the battery in another area I do not want damaged. I just want to melt the thin plastic to get the case off. Now we're getting ready to do a test run on this to see if this thing will work and how hot it gets. Kids want more food, ain't they?
Yeah.
See if I can get this here in here. Yeah, I got that in there. Now I'm gonna need you to turn the ABS on when I tell you. Probably need to take that in, possibly. Let's see if I can lay it down there and it'll stay in. All right, hit the ABS switch for me. Just for a second, be ready to cut it off. Hit it. Got it on?
Yeah.
All right, go ahead and cut it off. It's getting hot. That's about the right length right there. So it's getting almost red hot right there. So I think that's going to melt the battery. I'm going to try to get the camera set up here in such a way that I can get the whole thing in the shot when we cut the battery open here. See if that's in the screen. Turn it around where I can work on it easier. All right. Go ahead and hit it again. Turn it on. Cut it off. Where I'm burning to again. Getting a little bit too hot on the end there. Hope it's still in the camera shot. Turn it back on. Well, apparently I ain't got a connection. Turn it off. Try it again. Turn it on. And cut it off. I must have pulled the plug out is what I done. Pull the wire out of the plug here. Moving everything around too much. That's what I done. Let's try this again now that I know I've got connections. Alright, turn it on. It broke on the other side now, so I better cut it off. Alright, let's see if we can get this box opened up here. I'm going to work with it here a little bit. Maybe take a knife and cut down through there a couple times and kind of release any plastic that's on there, and then I'll see if we can get the top off of it now. I'll be in there and cut something I don't need to cut. See if I put a screwdriver or finish popping that on loose since it's got it weak already. There we go. Still got it connected on the other side. There's the BMS and there's the cells. Inside there, I gotta see where I damaged it and what's going on with it. But we still gotta get this other end loose and out. I don't know if I can get it broke loose or I might have to hacksaw it a little bit more. Let's leave it open a little bit there and take a break, and we'll come back to it. All right, let's see if we can get the rest of this apart. I got to figure out where the boards burn out at. It's probably this BMS right here burned out. Probably a place in the board. It could have burned out the transistors that switch everything off and on. We'll have to see. Either way, I'm going to either fix this BMS or we're going to go buy one. We'll go buy one, either one. plastic is tough as a pine knot. Still didn't get it all the way to whenever I was welding on it. Got a good part of it, but not all of it. I'll have to saw it a little bit more, I guess. Let's see if we can take the blade out. Might be easier to work with. Pretty thick plastic on this thing. Alright, we took the blade out. Let's see if we can be careful about going in there and not get inside the battery component area. We don't want to cut into them cells in there and damage them and wind up with a, I don't know if this is going to work out good or not. I don't know if that's going to work out good or not. I may need to take the razor blade and kind of slice across there until I get it all into what I may have to do. Got it close, but not all the way. I didn't want to melt so far in there I wound up shorting the battery out or burning into one of them plates and the battery spontaneously catch fire and just start burning and basically explode in my face. I don't want that happening. Let's see if I weakened it enough to pop loose whenever I put the screwdriver in there. I'm gonna feel kind of sick if this top pops right off. There it finally went. Wow, boy, that thing was on there. There's the connections of the wires. Here's the BMS. I expect something's burnt out here in the BMS. Looks like they had it taped on there good and had this stuff so the stuff couldn't move around in there. Up there anyway, there's the plates we had to be careful we didn't cut into. We got in there too far, we'd have cut into these plates and it could have damaged them. Had to make sure I didn't cut into anything. It doesn't look like it. But boy, she's awful close in there. Cut in there too far, you'll have them plates. This is the battery part right here. You cut into this, then the battery's damaged. You just might as well just throw it away. It's no good to be repaired or do anything with it. This here looks like the BMS here. That's it. We can pop some of this stuff off. It may have it taped on there. I don't know exactly what they got. I'm gonna try to put all this stuff back when I get done with it. Exactly the way I found it, so it'll stay. Keep the battery from moving around. We got that loose. Like I said, it may be the BMS itself it's got transistors and stuff through here that turn it off and on accordingly. And it may be it. It's blowed the transistors out. Sticky still on that and everything. So I can stick that right back on there. Looks like they got it taped together. And we got bushings in here to keep this thing from sliding around in the box. So, well, there's the BMS. Looks like it's a 1, 2, 3, 4, 5, 6, 7, 8 cell. Looks like it's an 8 cell system. So if I'd have got a 3, which I thought it was, I would have been getting the wrong BMS. And all these stuff is in here just for spacers to keep everything from moving around. Surprised they got all this glued real tight. They ain't got this glued. That can just fall around over here to the side like this and cause the battery to move around. So I'm a little surprised. Actually, one of them did move down in here. I'll get the camera in here where you can see it. Since it was made brand new, you can see it down there in the box. I don't know why this thing wants to be blurry, but let's try this again now. Right there it is. That spacer should have went right in here to help hold the battery. Like you got one down here. Well, no, actually it went down at the bottom, one up the top, one down here, but this one here's already slipped over and moved. So that's a chance over time with vibration or movement. These things can fall out of the way and it can start moving around in there and damage the battery. So that's something you might want to keep in mind, putting these batteries in an area that's got a lot of vibration. All right. I'll try to cut this on top, so I'm put the tape right back around it. I don't know if it burnt something in the board or not. Looks like I got some pretty hefty connections they got in there. That probably blowed out the transistors. If they short out, that could actually cause the battery to catch fire. See if we can cut this in here loose. Got the, I don't want to cut into that if I can help it. Daggone it. I want to pull this up and then cut it. I don't want to cut in that sticker because that tells me what model and stuff I need to go ahead and get another replacement BMS to put in it. Like it's a Chinese battery. Alrighty. Right there's the sensor. Look at there. They had the sensor up here on this thing. Look at that. Had the sensor up here instead of having it down here where the batteries are at, where the batteries could get hot. In other words, these batteries could heat way up and have to heat this board up and everything else around this area before this sensor detected that the batteries was hot and it needed to shut the BMS off. That sensor should have been put down here where the batteries are at. See if I can get this out without damaging it. That sensor should have been put down in there where them batteries are at, down in there where it could detect the heat off them batteries much sooner than having it all up here and on this. So that's one thing I see it's a bad mistake on these batteries. But the BMS was working like it's supposed to, because it blowed out and stopped functioning about as soon as I tried to power the inverter. So let's see if we can get this here BMS out, and we got a Phillips screwdriver here. So we can get them screws out and see if we can get this thing fixed. Yeah, they even got a heat sink right here. They got something here. So that these batteries could have got extremely hot before that sensor would have detected it had a problem with the battery and shut the system down if it was being overloaded. But I guess they realized the BMS was so cheap in it that it would blow the BMS before you pulled enough amps to heat the battery up for, you know, overuse of the battery. Well, there's the BMS. I'm going to try to get this here covers off, which I don't think is nothing I'm going to be able to see. Yeah, I might get this off and take the screws out of it. Looks like it's got heat sinks for all these transistors down here. I might look and see if it blow the area of the board. I'm going to try to get all these covers and stuff off, and since I get that off, I'll get back with you on the video here with what we're doing to try to see if we can fix this BMS. All right, we got the heat sink off, and I suspect that it's probably blowed every one of these transistors out right here. The board here turns these transistors on and off to allow power to flow in or shut the power off if it's being overloaded. So I suspect every one of these transistors right through here is shorted out. Well, I ain't say it's shorted out. I say it's got an open circuit to it. And they are definitely required to send power, you know, from this negative part of the battery to the output of the battery. So right from this point right here on these to this, well, I've got an enormous amount of power. This here's what controls that power. You know, you would think as much technology as they put in these circuit boards to fix all these delicate little circuits to control this battery, they would build this circuit strong enough to carry enough power and simply put a circuit breaker right here on these two wires from this point here to this point here, so it would trip out if it was to go into a real hard short rather than blowing the board up. So they're very smart to be so dumb. They build something like this so it works, but if you make a small mistake with it, then it winds up burning the whole system out instead of having a circuit breaker that just trips out whenever it gets overloaded. So I'm going to take this in the house. I'm going to test some circuits. I'm going to look on the board and see if it blowed up any parts of the board. But as far as I can tell, it may have blown the layers underneath the board. I'll have to look. Yeah, right here's where it blowed part of the board out right here. I see right here where it blowed the board right here. I don't know if y'all can see that in the camera there, but it did blow the board out right there. So if that is where the power goes in here, then that could be where that is designed to blow the fuse. So this here right in here is the actual fuse of this thing. I'm going to get this under some magnification, but I don't know if you can see it on the camera. Let me see if I can zoom in. I don't know if you can see it. I get here in the light. But right here in the board, right here, you can see where the board has blown right here, where it goes from here over to this, and it blowed that circuit there. Now, if he's got a little teeny tiny circuit up through here on each one of them terminals that makes connection to this, it may have just simply lost its solder joint from this connection here over here to this connection on every one of them up through there, and that's what it looks like it done. It broke the solder right here on this joint, broke the solder here on this joint, broke the solder here on this joint, blowed the solder out right here, blowed the solder out here, blowed the solder out here, blowed the solder out there, and blowed the solder out here. That's what it looks like it has done. So I'm going to get in here under a microscope and look at this, and I don't have a camera to show you under a microscope what this looks like under a microscope, but anyway, it definitely blowed the board out right here, and I think it's got every one of these has got a little teeny tiny area where it's got a small fuse in it, where it's made to blow the board out rather than shorten these out. It blows the board and opens the circuit. So I think that's what's going on with this BMS. So I'm going to see if I can take this in here, do some tests, and look at it under a microscope and see if I can't get it figured out what we need to do to get this fixed. But I think we might be able to fix this board here. All right, guys, I hope I can hold the camera still enough where you can see. I'm a little bit shaky, but I wanted you to see right here. Get everything lined up. You can see right here where this blowed out here. Well, it blowed out right here. Let me see if I can zoom in a little bit more so you can see it better. It blowed out right there on each one of them. Right here it blowed out. Right there it blowed out. Right there it blowed out. And it blowed out here. Blowed out here. And blowed out there. See here with me. So it blowed every one of them out where it goes in to them transistors here. You can see where it melted it. When it blowed out, it just kind of wreaked havoc on everything. You can see here where it blowed out, blowed it up in here. So it blowed it out right there. Blowed it out from here to here. Let's see here, put there, yep, blowed it out from there to there. See where it burnt the board all across there. Right here the same way. And it burned it out from here to here. So that's why the battery went with the open connection. So I'm going to try to get all these soldered back, connected up. Be careful when I connect it up, because if he's shorted out, it could cause the battery to overload itself. You know, shorting back through maybe these terminals here, and could cause it to, the battery to overheat. So I've got to make sure that I ain't got too much power being pulled. I don't think this over here could be shorted, because these wires are so small going over here to control these components. I think it would just burn the board out right here, and it wouldn't short the battery in a way that it would cause it to catch fire. But anyway, I'm going to resolder all these joints back right here. Here, all the way down the board there. Then we're going to hook this thing up and see if that fixed the problem. And if it did, we're good to go to get this battery maybe put back together, and we'll be able to use it a little bit longer. If not, we'll probably look at buying another BMS or buy these transistors. And thing of it is, if these transistors shorted out and fed power back over here to these other transistors over here, it takes maybe 3 volts or something, then we'd have to be changing these transistors, integrated circuits here out. So if these were actually burned out, I think it'd be the fastest and cheapest way would be just to replace the whole BMS rather than trying to replace all these little transistors that control the regulation of power, and, you know, that controls these particular transistors. Or these things here turn these off and on accordingly. And if power fed back through from it shorting out back into this, it probably blow these integrated circuits out. So if it done that, we're going to just need to replace the whole BMS. It'll be better just to change it than trying to fix this one. All right, guys, we're getting ready to get this thing soldered up. This is the kind of solder flux I'm using. I've got this thing zoomed way in so you can see a little bit better. But anyway, I'm going to flux it up with this, and my solder's got flux made in it also, but that'll help make sure that this solder flows good. And we get this here soldered back up good. We got all that fluxed up good. Let's see if we can get in here to get this thing soldered. And like I said, my soldering has got flux built in. It's a rosin core solder. So anyway, I got me a huge roll of it. But anyway, made in China. You seem like you can't get nothing in the USA no more. It's just everything comes from China. It seems kind of ridiculous anymore. All right, let's see if we can get this thing here soldered up. Let me get my other glasses on where I can see just a little bit better. I have to use 2 pair of reading glasses to magnify this thing up good so I can see. I can actually see better on the camera than what like you guys can, than I can see, and y'all can probably see better than I can on the camera with it zoomed in than what I can see. So let's see if we can get this here flowed in there. I got to get all this good and hot. This soldering iron may not be a high enough wattage. It may not be a high enough wattage. I may have to use a bigger soldering iron to get that. It feels like it's getting some hot. I got it set at 800 degrees Fahrenheit, so I feel like it's trying to bond, but it's a little bit on the cold side, so we have to give it a few minutes for it to flow properly. That soldering iron is set on the maximum temperature I can get it to set on, but it don't look like it's wanting to flow very good. And I do want to get that solder good. And I suspect over here on the other side of the board it's going to be in the same condition. If I put too many amps on it, it's going to wind up blowing the board out on the other side also. So I would like to get a good solder on that piece there, but it just don't act like that solder wants to flow very well. Have to give it a little bit of time to heat up. I may have to use a gas soldering iron. It gets a little bit hotter. All right, I'm going to stop the video here, guys. I'm going to get my gas soldering iron out. I don't want to be heating that board up real hot. It's probably got layers in it. I want to heat it up, get it done and over with. I don't want to have to be sitting there just keeping heat on it constantly. So let me get me a different soldering iron, and I'll be right back with you. All righty, I got my gas soldering iron here on. I ain't got enough, probably getting a bit low on gas. Let's see if we can get this here thing to flow right. I think I may have run out of gas. I'm going to have to do some work on the soldering iron. It ain't up high enough on the blaze. So let me do that work and I'll be right back, guys. All right. I took my gas soldering iron apart. Cleaned it. Opened up the blaze a little bit hotter on it so it's get hotter. That's it. This here will melt in and flow properly now. Takes a lot of heat for these type of boards. If it gets hot enough, it should. Make sure I don't get something else. There's a lot of heat. I can't even feel it where my fingers are at. There, it finally flowed. Man, it seems globbed on there because it didn't get the whole board hot. Seems like it's a little bit globbed. Board here's getting pretty warm over in here where my fingers are at. Well, I'm going to have to go a different route with some of this. I guess I might get this thing up on a platform and hold it up and see if I can't take my blow. See if I can't get it warmed up enough with this so I can get it to take a solder, heat it from the bottom, and then use a soldering iron from the top. See if I can get this thing to flow right, because this simply ain't doing right. I'm going to see what I can do with it here. Alrighty, I had to set this up outside. I didn't want my wife breathing fumes. I'm going to have to wind up using my heat gun right here. She's going to have to hold it there for me like that, while I take the soldering iron here and see if I can't get the solder to flow. So we're going to use both these components together, and she's going to have to help me, because I've got to have solder in one hand and soldering gun in the other. So I'm going to have to try to get all this rigged up so that I can get this soldered. And I put some Capcom tape on this board here to kind of reflect any heat. So all the heat's basically over in this area, and I don't want it on these components at all. So we're getting ready to see if we can get this soldered up.
Where do I put this?
Yeah, you can set that down right there. We're going to see if we can get her over here with a heat gun, holding the heat gun for me. Going to try to get it warmed up to about 200. I think it's 260. I think I've got this thing set. No, it's 241. I got the blow gun set for 241. I'm going to have her over here holding the gun right here for me. If you'll just hold that gun just like that right there for me, Renee, I'll appreciate it.
This right there?
Just hold it just like that. Let it blow on that board there. I'm going to try to get the solder in here around. What we're trying to do is heat up that board a little bit so it'll help the solder flow better. And right now it ain't flowing good at all. Keep turning the hair up a little bit. That's wide open on the air. Let's keep it on this component right over here. We want it just to blow right down through here, okay? You got it over that way too far. Bring it back.
I'm doing the best I know how. I really need.
Let the board heat up a little bit more. Wish I had a... Need you hold just like that, Renee. Just like that. Thank you. Like the flux is starting to flow a little bit. I'm gonna zoom in where you guys can see it a little bit better, maybe. I have to bring the temperature up when I'm hitting the camera here. Let me bring the temperature up a little bit. I'll put it on 299. Let that heat a little bit. Hopefully I'll get this solder to flow here shortly. Get a little bit more light burning here so we have a little bit more light. I don't know if that will help. Let me get the one on top here going. See a little bit better. Give us a little bit more light there. Let your hand rest on the battery, be fine, but just keep that heat right here. We want it to blow on this more than them transistors there. So if you can hold that for me right there. I feel like it's trying to flow a little bit better. Turn the heat on up to about 350, 360 right there we go. That's just below the melting point of, actually it may be a little bit hot for transistor. Let me bring it down to 315. So I've got to get that whole board hot before it'll take a solder. I can get this solder to flow it, and we'll have this thing fixed, but it just solder iron wants to stick to it. When it goes to it, it melts it momentarily, and then it wants to stick to it. Right, let me see here if I can do it. Go ahead and hop out of the way for a minute, Renee. I'll put that directly on it here off of the other components. We want it to blow down through there. I need to get me a better setup on my camera where people can see what I'm doing without the camera being in my way. I'm trying to get this here solder joint right here to solder. That air blowing off of that gun is sure warm. So you can see the solder iron wants to stick to it. It wants to stick to it right there before it, when it starts melting into it, it wants to stick. I hope every one of them ain't like this. If I get this thing warm enough, it'll flow over to it. I'm actually starting to get it to flow a little bit now. Give me another light, please. I ain't got it on there yet. It's flowing near it, but not on it. I need my other reading glasses. If you don't mind running in the house grabbing them, I need to be able to have this thing under a close magnification. It's real close about soldering though. You need to get the flow over there to it. That's going. May have to use the gas soldering iron with this. I don't know. I'm having to heat the whole board to get this thing to flow properly. This whole board's having to get hot. Whole entire board. Wish I had a holder for this thing. I'll just put that right there and leave that on there. Get my glasses on here. I'll know in a minute if I got that bridged across there. Does it blow the board out? Do I not have them?
No, they're not in there on the table.
Let me put my soldering iron up. Alright, I might go get my glasses, guys, so I can see a little bit better. I'll be back in a minute.
Cause I don't see my.
Well, we found my glasses. They were actually over here. Side of me. Didn't realize it. Yeah, actually, I do have that bridge across there now. It looked like crap. I wish I had a little bit more heat. I need you to just hold your hand right there, and if you'll hold that on the board just like that. I might need to use a little bit smaller tip. Anyway, if you'll just let your hand rest right there and hold it like that, I'm going to see if I can work with this. Go ahead and keep it off the transistor. We won't heat this side of the board up more than we are the other side.
Well, I'm okay where I'm at.
That looks good right there, Renee. Thank you. I'm soldering iron's out of gas. The gas in the truck.
Yeah, it should be in the floorboard.
Alright, with both these, I think we might be able to get this thing to bridge properly
Okay, where I'm at.
for the moment. Get this soldering hot. It don't take long for this thing to get hot. And it's already hot. I just lit it and it's already getting hot. It don't take long. Back up just a little bit. This is crazy. The other soldering iron seemed to do better than this one. This is a real hot one here. Yeah, that doesn't seem to be doing better than this one. That and there's. And this one here was flowing better than the other one. Yeah, that flowed over very good. Let me see if I can get this other one here. did get it on the transistor good. I don't know why that one wanted to be such a pain in the butt, but this one here taking right off. Well, I see what it is. The closer I get over here in this other wad of solder, the more heat it takes to get it to solder. That's exactly what it is. Get that in there, upload good. I like to get that over under solder so that it will carry enough amps so it don't blow out again. I've done this every day, this kind of work. I want actually would probably get me a workbench and fix me up something where I would be more comfortable. Right now I'm standing up, bending over. I'll make sure that ain't bridged. Yeah, I didn't bridge it there. That board's pretty hot. It'll burn your fingers when you touch it. I did get it soldered. I got a lot more solder on there than what they had whenever they built the board. The little thin piece of copper right there. They didn't have nothing on it right there to hold it. Almost got that bridged right there. Almost there, guys. Bring it down a little bit closer here. Put it right here on this. Melts it momentarily, then the soldering iron cools off, and then it kind of freezes back. Even with the heat gun. I'm going to check it here in a minute with the ohm meter. Make sure we got connections there, but it's got to be better than what they had in the factory whenever they had that little cheap copper around across there doing all that amps.
Is that part of the camera? Ain't on part of the camera?
Huh?
That part you're at now ain't on the camera.
Thanks for telling me. I didn't realize it. Got my eyes on trying to focus on getting these connections here made. Hold it a little bit closer, please. This ought to be real easy to solder here. Well, we got it bridged across there. All right, back off for a minute. Let me kind of check this out. I'd like to see, put a little bit of heat right here. I'd like to see this a little bit better right here. heat right in here.
There it goes.
Right there. Down a little bit. Right there. That board is the hardest board I've had to solder yet. You have to get the whole board hot just to be able to solder something. All right, go ahead and remove the heat. Barely do have this connected. Put your heat back over here. Let me put a little bit more on this. Thanks for noticing. I just barely got this in here bridged. This in here just got a little piece on. Put it right here. Right there like that. Thank you. I just barely got a piece of solder right in here to bridge this. All right, I got that bridged. We add a little bit of solder right here. Make that look a little bit better. Right, that's bridged. That's bridged pretty good right there too. It's a lot thicker than what it was before. And I suspect if I put that kind of amps again to it right here, show you guys here in a minute what we're looking at.
Oh, you want to take it off?
Yeah, take that off for a moment. Then I got this side here fixed so that it'll carry enough amps. Get over here where see better. I suspect every one of these right here, that's bridged right here on this, these here will burn out next. Because I might find out which connection here to here, but I might actually want to need to go ahead and just add some solder to all these so it don't burn out like it did. But I'm going to tell you, it's really hard to get this to solder. I don't think I got it bridged there, but it wanted to glob at first, and when the board got hotter, and I'm going to check the connections between here and here, make sure I ain't got no bridge in here between them that resistor. That's what triggers it. I think that's a trigger resistor there. That's what triggers it in transistor. I got to make sure that ain't bridged. But I think I did get it soldered. I'm going to tell you, that's the hardest board I've soldered yet. You had to heat the whole board. Alrighty. We cleaned it up and checked our bridges. It doesn't appear to be bridged. However, I did make all my connections across there, so I guess we're going to try to put the heat sink on it. This item right here is what they had on it. They had this here on it. Had it bolted down on a pad, which is kind of strange, but that's the way they had it. Had it on there just like that. Kind of a little bit sticky, and I got this here to transfer the heat, I guess, overall onto it. So we're going to go ahead and get the little screws in it. Get this thing bolted back together. And get this back in. See if we can hook it up and see if it'll throw any power and see what it does. If it burns up, because something else is shorted out, I guess we'll soon find out, because when we hook it up, we'll know. I'm going to also need to do a charge on the battery and make sure that the BMS trips out so it doesn't overcharge the battery. If it doesn't trip out, then the BMS is damaged. We will have to actually replace this BMS with a new one to ensure the safe operation of the battery. But anyway, I'm going to go ahead and get all these little screws back in this heat sink. And I think I know why they put the sensor on this particular thing here rather than putting it on the battery. They was assuming this would get hot before the battery would. So this would, if it detects the transistors getting hot, it actually trips out the BMS on the transistors versus the battery getting hot and tripping out. But you'd think they'd make a BMS capable of doing what the maximum amount of that battery is able to do. But I guess they got the BMS as the weakest link to ensure that you don't overload the battery And if you do overload the battery, it blows the BMS up and not the battery explode on you and catch fire and burn the house down. So rules and regulations may have it set up that with OSHA and everything that they have to set it up that way, but a simple circuit breaker on it could trip out. And then it trip back in, out and in, out and in. If something was shorted, and it could eventually heat the battery up and explode. So they ought to put an external circuit breaker on this particular battery. So if something was too short, you know, a tripped circuit breaker that you can reset back in. And once you set back, then you could set the battery back up. But anyway, I've got to get all the covers and everything back on this thing, and got to get the BMS back in the battery here. Get my covers and stuff over here. Like you hit this cover here on here to kind of protect this from rubbing the battery. Look, that's stuck good. And I'm still debating if I need to put this on the battery or put it in here, back in here the way they had it. You know, they think that they would have this actually glued to the heat sink here so it could detect the heat off them transistors and trip out. I'm not sure how I'm going to do this, but this here actually needs to either be connected here like this on the board or down here on the batteries to detect the heat in the batteries. I expect these transistors will get hot before the battery does. So I'll probably best to have this here heat sink, the probe for the heat sink up here on the aluminum. Anyway, let me get the covers back on everything here and get this back on and see if I can get this here set up where it was sitting before. I think I know what I'm going to do. I'm going to actually take this here back up, stick this probe right up underneath that piece there, so it actually pushes that probe down on the heat sink and keeps that probe in place right there. That's where I think I'm going to put that. Let's see if we can get the tape back on it. Wish I had some more of this type of tape. I don't have none with me. Get me some more tape, get me some tape like this so I can kind of continue to I'm going to get me some more tape for sure. And I would have to get this up underneath that when it needs to go across the top. I'm going to go in here and get some more tape. Put me some more tape on that right there. So let me run in here and get some more tape so I can keep that thing pushed together and down on that. Alrighty, I got me some tape here. See if I can't get this tape in there a little bit better than it was before. That probe down on there, where it's pushing on the heat sink where it detects the heat. I had to lay it in here before. I think I got my tape right in the way there. I think I can make that connection. All right, let me get my screws over here. hope this works. If it does, we're back in business. I got my battery fixed. Use it again, but I'm seriously thinking about putting me a bigger BMS in it so that I can use the battery for cranking a vehicle. That heat probe right here, if I put a bigger BMS in it, I'm gonna put it on the batteries. So if this battery starts getting warm, it'll cut the BMS off and prevent the battery from getting too hot. So if I do get a 500 amp BMS to put on this thing, that temperature probe you see right here will go on the batteries down there. So if the batteries start getting warm for overuse, they don't catch fire and it'll cut the BMS off. So that's the way I plan on doing that. Let's see here. Get ready to put a test light on here, but we'll see here in a minute what happens to it. Right now we shouldn't have no power going through it at all because I got the BMS unplugged. So I'm getting ready to check that now. We ain't got no power on the leads, and that's telling me that the BMS is not shorted in any kind of way. So when I get ready to charge it, it should cut it off. Got my test light here. Should cut the battery off whenever the battery gets fully charged. So you do not want to overcharge them. Let's see what we got here. We shouldn't have no light burning. Well, actually, we do have a light burning. Okay, let me check the voltage on that because that's going to make the difference. I had a light burning when the BMS was burned out earlier. So we need to check and see if the voltage drops and see what it does. That BMS actually may be shorted out where it's leaving the battery on all the time. And if it does that, then the batteries can be overcharged and it can cause it to catch fire. So we got to make sure we're careful with this. Let's get my meters back on. Let's get this on the voltage. 13.25. The voltage should drop. Yeah, 12.94. So it actually seems like everything is actually working. Let's hook this up and see what happens. All right, that's plugged in. All right, let's plug the charger into it and see what it does. It seems to be working now. That voltage is dropping a whole lot though for a little test light, so I'm kind of concerned about that matter. It may be that part of that BMS is burned out. All right. Here's my leads. Let's hook the positive up. Negative up. Test light disconnected. Okay. We got it set for 13.4. Let's set it on up here to let's see what it does now. No, sir. The BMS is not working. That BMS is not working. So that's why the voltage dropped on the test light when I hooked it up. Apparently it's got something else burnt out in it too, besides them pieces, because it's not charging and the voltage drops. So we're gonna look like we're gonna have to put a BMS in this battery if we're gonna make it work, or I might take it back apart and see what else it may have burned out. It may have burnt them transistors out whenever it jumped over like that. But anyway, she ain't working right now, and definitely ain't charging. Yeah, I definitely got power. Positive to the positive and negative to negative. No charge at all. And just for kicks and grins, I connect this up without the BMS. Let's just see what it does. I'm certain it'll charge because it's the BMS shutting everything off right now. The BMS has got an open circuit on it. Yep, it goes at 10.20 volts or amps. And it's 14.6 volt right there. So it's definitely a problem with the BMS. It'd have been nice if I could actually fix it, but looks like we are buying another BMS and we're gonna get this battery up and running again.